For the second part of the audio lecture, I'm again just going to go through the SPSS as kind of a precursor to your lab. For the ANCOVA blocking, so this is when you have a categorical covariate. Now, if you were actually intending for you to, if you were planning to use a continuous variable as a categorical covariate, you would need to already have created the categories as a separate variable. So that would be pre-analysis. So this is you already have an existing categorical variable and you're wanting to use it as a covariate, but you're wanting to basically use it as a blocking categorical covariate. Now the main thing here is we're basically needing to take one additional step from what we would normally do with ANCOVA, and that is that we need to add that categorical covariate, but we need to add it in such a way that it is not going to be made into interaction terms. So that's really all we're doing is we're adding it as a predictor, but then we're telling SPSS, don't treat it as a predictor. Don't look for interactions, simply account for its variance and remove it. So we're going to start with, as we would with any ANCOVA, analyze general linear model univariate. It's going to take us to this screen. And again, we're going to take our continuous DV, we're going to click it over to dependent variable. We're going to click our IV and bring it over to fixed factors, but we're also going to click our covariate and also bring it over to fixed factors. So at this point, we're treating it as a predictor, a categorical predictor. So if we just continue to forth as we normally would, we actually wouldn't be running a covariate, we would be running it as a predictor. But we want to let SPSS know all we care about is it predicted to the outcome? We're not interested in its interaction or how it relates to the other predictor. So we're going to click model in this case. And in model, we're going to hit custom. We're going to click on our IV or IVs, bring them over, and we're going to click on our categorical covariate and bring it over. Now notice there is a build terms to build interactions, etc. that we could add at this point. This is also a useful screen if you want to look at some interactions but not all possible interactions in a more complex factorial ANCOVA. But at this point, all we've told it is we're interested in the condition, our predictor, our IV, but we also have phobia as a a categorical covariate, but we do not want to look at any interactions or any other relationships within the model. Now note, if you had two predictors that you were also interested in looking at their interaction and a categorical covariate, you would bring the first predictor over, you would bring the second predictor over, you would build terms, the interaction between those two, and then again, at the end, you would bring over your categorical covariate, phobia in this case, without making any interaction terms. Once we've done that, we're going to hit continue. And at this point, it's pretty similar to what we've done with, again, any other ANCOVA. We're going to hit post hoc tests. We're going to bring over our two predictors, including our covariate, just to go ahead and see how it's related to our outcome. We're going to select two keys, and we're going to hit continue. At this point, we're again going to hit options, and in options, again, we're going to tell SPSS to give us means. Not a bad idea to bring them all over, again, just to kind of get an idea of what's going on with that covariate, even though we're not necessarily interested in the means of the covariate. And finally, we're again going to ask for descriptive statistics, effect sizes, and the homogeneity test. In this case, it would be a Levene's test. Again, we're going to click continue. And at this point, we're going to click OK. And this is the first thing we're going to get. First thing we're going to get is our dependent variable as it relates to both our condition, and in this case, our condition had 3 levels: desensitization, implosion, and insight, and our covariate blocking, which was mild, moderate, or severe phobia. And again, we have all our means there, and we also have our Levene's test, which again, we want it to be insignificant. We want it to have a p of above 0.05, but honestly, we can even accept it down to a p of 0.01 before we're really that worried about it. And again, we can see our IV's means and standard deviations in this table. So desensitization, regardless of your level of phobia, implosion, regardless of your level of phobia, and insight, regardless of your level of phobia. Now we're going to get our test of between subjects effects. And again, we're going to see our covariate phobia listed right here. So how much variance is accounting? It is significant. It's accounting for a fair amount of actual variance in our outcome. We're also going to see our independent variable, and again, it is significant in this particular case, and again, our error term. We're also going to get our two keys post hoc tests, our multiple comparisons. And again, from here, we're going to be able to look at our significant differences specifically in the variable we're interested in, which was desensitization, implosion therapy, or insight therapy. If we're doing it as a continuous variable, it's a lot simpler because there's actually a block for us to put it into. We don't actually have to go into the model at this point. So again, we're going to go to general linear model, univariate. Once again, we're going to bring our continuous variable over to dependent variable. We're going to bring our actual hypothesized predictors over to fixed factors. And our continuous variable, that is, again, a continuous covariate, we're simply going to bring over to covariate. We're basically telling SPSS, run a multiple regression first and remove that variance. And because we're doing that, it's not going to try to create interaction terms, because interaction terms are generally created with categorical variables. Again, we're going to click options. We're going to select all of these. We're going to bring them over. We're going to, once again, click descriptive statistics, the estimate of effect size, homogeneity test. Once again, we're going to click continue. And again, we're going to get information. We want that Levene's test again to be insignificant. We're also going to get two tables of means. Basically, the estimated marginal means represent the means once the covariate is introduced, and it usually will be slightly different than the means without the covariate. However, the means without the covariate is what we actually want to report. So notice there is a mean difference here as how far of the difference. In this case, there would actually be a little bit of descriptive information that potentially our covariate is hurting us, not helping us. There is a smaller difference with the covariate in the model than there is when the covariate is not in the model. This would probably indicate that in this case, our covariate is actually related to our predictor as well as our outcome. Once again, though, we're going to get this table. We're going to find the covariate, in this case, extroversion. We're going to find our IV, and once again, we're going to find our error. And in this case, we actually find that our IV is insignificant. Significance is 0.07 with the covariate in the model. If at this point, especially considering that we saw such a change in the effect size from the means without the covariate and the means with the covariate, this would probably be a good indicator that we might not actually want that covariate in there, that extroversion might be just as related to alcoholism as it is to our outcome sensation. So in that point, we may actually have been making the model worse by taking effect size off the top. In other words, our covariate extroversion was just as related to our predictor as it was our outcome. So the biggest thing to realize is that all of these things, whether it is how many levels you have in a categorical variable, how many categorical variables, how many interactions, whether it's a factorial model, whether it's a between model, whether it's a within model, whether it's a mixed model with both between and within predictors, and finally, whether or not you have covariates, are all just adding layers to the same concept. So just recognize that we still need to check assumptions. We still need to conduct post hoc tests, we still need to report effect sizes when significant, and we still need to examine interactions and simple and main effect tests if they're actually hypothesized. So again, just recognize that the toolkit that we've been going over the last 3 to 4 weeks has been a series of things that we can do with ANCOVA. And ANCOVAs, much like multiple regressions, can become extremely complex, but all we're doing is adding more and more layers of the same type of analysis. If we have a single predictor that has more than 3 levels, we're going to need a post hoc test if it's significant. If we have multiple predictors, all with more than 3 levels, we may need post hoc tests for each and every one of them. Every time we find a significant interaction, we're also going to have to look for the simple main effect test to ask where is that interaction. And again, when we're entering covariates, we need to make sure that we know what we're doing with those, that there is a theoretical reason to have them in there, i.e. we don't have a hypothesis and they're related more likely to the outcome than the other predictors. So again, it's a lot to take in, and I'm not necessarily expecting you to have all of this in your head. This is more about getting a feel for what all we can do and how complex it can become, but also recognize that the most complex ANCOVA model possible can still be broken up into these individual components that we've already handled and discussed.